6.5, number 4. Let x be a random variable that represents the level of glucose in the blood after a 12-hour fast. Now, assume that for people under 50 years old, here's what we have. I'm going to write some of this down here. So standard for people under 50 is, the mean is 72, and the standard deviation is 50. Okay? Now, a test result less than 40 is an indication of severe excess insulin, and medication is usually prescribed. All right, so the standard is 72. If you get under 40, severe indication of severe excess insulin. All right, so what have we got here? So A says, what is the probability that on a single test, X is less than 40? So I'm going to write that down. I'm looking for the probability that X is less than 40. Now, when I do these problems, I always like to draw a picture. Helps me get an accurate result so I know what it is I'm doing. All right, now the high point is the mean, which is 72. We're here at 40. That's to the left. And we want less than 40. So we want, what's the probability that you take, right? Here's the X values. Those are all the X values right here on this axis. Those are all the glucose values. What's the probability we take a random sample and get a glucose value of that number or down in that interval right there? We're going to measure that by that area right there, right? That is what that is right there. That's the probability that X is less than 40. All right, so let's just go straight to normal CDF, right? And now what does normal CDF want? It wants the lower limit, it wants the upper limit, it wants the mean, and it wants the standard deviation, and then we're going to paste and compute. So what is the low? Now the low, look at your pictures. Why it's nice to have a picture. What's the low? Well, this goes all the way out to negative infinity. Now, by the diagram, this area goes to negative infinity, right? The area, the interval goes to negative and 50. Practically, though, what's the lowest blood glucose level you can have? Probably is 0. I'm still going to use, because I'm doing it theoretically, I'm doing it with my picture, I'm still going to use the picture to do this. So I'm going to claim now that this is going to be the negative E99. Now, if you wanted to, you could try this. Put in like maybe 100,000, or even try 0, see what happens. We might try that right at the end here. Now, the upper limit, 70, no, what is it? 40. The mean is 72. Standard deviation is 50. Let's put those numbers in and compute. So when I computed, I got this number here. I got 0.26108. Now let's just check what we're supposed to do here. It's a probability, so I'm guessing we want 4 decimal places, and sure enough, that's what we want. Pretty typical in probability. So we'll round up. So how about 0.2611? Let's report that up here at the top left in part A, 0.2611. Now, just to try something here, let's see what would happen if instead of using this negative infinity here, we used 0, thinking, okay, that's the lowest it could be. Well, if you put 0 in and run that test, I came out with this, 0.18615. You know, that's substantially, these two numbers are pretty different. I'd be suspicious of this number here. Why would we not use 0? Because we are using this curve, and the curve does not really stop at 0. 0 would be right there. It would stop there. We're missing a lot of area, a lot of probability. And then, just out of curiosity, I tried this one. I went away from 0 and I put in negative 100,000. All right, so when I put in negative 100,000, I got this, 0.2611. Okay, so if probably from now on, if you wanted to use negative 100,000, that's probably good enough. Or the negative E99 if you remember how to get it, which is what? Second. Right above the 7 key, you see that comma key, and on the comma key is the EE. That's where that is. And then you, of course, need the negative sign first. Now, part B says this. Suppose a doctor uses the average X bar for 2 tests. All right, so in this case, what we're going to have is that not just one test, but N is going to equal 2. I think my 50 got lost there. All right, so what can we say now about the probability distribution for X bar? Okay, well, X bar is always normal distributed. All right, so let me see if I can actually draw this. So X bar is automatically normal. Now, X itself, you don't know about X, but what were we told back here? All right, so X bar is normal. Now come back here, back in here. We're told that X is normal. So because I'm told X is normal, I can do this part A. But I don't need to be told that for part B, because part B we're taking an average, and averages are automatically normal. So which part do we use here? The probability distribution is not normal. Well, that's opposite. Distribution is approximately normal with the mean 72. Sigma, oh, you know what we're going to have to do here is we're going to have to compute sigma. So for X bar, the mean of all the means is actually the mean of the population. So for us, we can use 72. But the standard deviation of those X bars, that's equal to the standard deviation divided by the square root of n. So let's compute for ours. All right, so for us, mu is just still equal to the 72, but the sigma is now, sigma sub X bar is going to be sigma over the square root of n, which is going to be 50 divided by the square root of 2, and I got 35.35. All right, so I want that one, and I want that one. Let's see what we have for our possible answers. So the first one is out because X bar is normal. The distribution is approximately normal with the mean of 72, and the standard deviation is, okay, maybe I rounded off differently. All right, I think it's going to be this one here. That's too far off, too far off. All right, so let's go with this one. All right, I'll go with that one, second one there. And now, what is, oh, we're still in part B. What is the probability that X bar is less than 40? So the first part A, what's the probability that a single value came back, a single test result came back less than 40? That was going to happen about 26% of the time. What if you take two samples, a sample of size 2? You take 2 and get their average. Right now what we're looking for is this. What is the probability that X bar is less than 40? All right, so we have a picture up there. I'm not going to draw another one. So now what we want is this. We want normal CDF again, all right? But here's what we're going to have. For the lower limit, upper limit, mu, and sigma, all right? The lower limit we still want to be 40? Yeah, 40. No. What do we want for that? That's not right. Let's put in the negative E99, right? Negative E99. Upper limit, that's our 40, right? Because what are we doing? We want X bar to be less than 40. So it starts here at negative infinity and goes up to 40. Now mu, what's the mu? These are actually the mu's of the X bars, which we know is mu, which we know is 72, and the sigma sub X bars, this is where we get that sigma over the square root of n, which was, what did we get for this? We got 35 point, I'll round off a little bit better this time. All right, let's put these into our calculator and compute. Now, I got 0.1827. All right, and that's good to 4 decimal places. So I'm going to claim that that's my answer here. So, but up here, right here, 0.1827, 1827. Now, part C, we'll look at part C and D. Part C, we're going to go with 3 tests, and part D, we're going to go with 5 tests. So let's run this for 3 and 5. So for my low, I'm going to put in the e to the negative E99 My upper, I'm going to put in, we still want the 40. Now, what is mu? All right, mu is still going to be our 72. And what is sigma? Well, this is going to be, all right, now you can put it in just like this. Put it in 50, press the divide key, press square root, which is second x squared, and then put in 3, and then press enter, and just compute, all right? Now, I got 0.1338. I'm rounding off to 4 decimal places, all right? So up here in our part C, I'm going to write 0.1338. Now, for part D, let's be efficient. Here's how we can do this on our calculator. What I want is I don't want the 3 here anymore. I want all of this. I want all of this to look like this, except I don't want a 3 here. I want a 5. All right, so do this. Press second. And then down at the very bottom right, you see an enter key, right? We all know where the enter key is. But right above enter, it says entry. Now, if you press second and entry, it brings back the last thing you typed in. But it's bringing it back like this, right? You can't really see it, but it's normal CDF. It brings it back in this form right here, right? It's bringing it back as negative E99. Then maybe you can see the 40. You can see the 72. And then you can see the 50 divide, and then you got the square root. Now run the cursor, right? Right now what it says is, right now it's saying 3, right? It says a 3 there. All right, so run your cursor over to the 3 and put your cursor right on the 3 and just type a 5. It'll just type right over it. And then press enter. Now when you press enter, I'm coming back with 0762. All right, so 0762. Doesn't look like 0762, but it is. So I'm going to write that up here, 0.0762. Now, part E says, compare your answers to parts A, B, C, and D. Did the probabilities decrease as increased? Okay, well, N, that's our sample size. We went from what? 1 to 2 to 3 to 5. Now look at the probabilities. The probabilities are decreasing substantially. So let's say yes to this, and then there's going to be a question. Explain what this might imply if you were a doctor or a nurse. Well, it seems like if you take a test once, the probability of an indication for excess insulin is 26%. If you take it twice, take the test twice, that probability is 18%, and then 3 times is, okay, what does this mean? There's a 13% chance that you would get that result. Up here, take it once, 26% chance you get that result. Take it twice, and you're seeing that result, there's only an 18% chance of getting that result. You take it 3 times, now the probability of seeing your result is 13%. What if you take it 5 times? Now it's down to 7%, right? But you're seeing that result. You're seeing less than 40, but the probability is now down to 7%. So I think what we have here is the more tests a patient completes, the stronger is the evidence for, okay, I think for excess insulin, that's what we're testing for. All right, so this should be, I think, for excess insulin. So I'm going to claim it's the more tests, the great, stronger. Okay, I think it's that one right there.